So the plan for today, we're going to add a heat map for the output to visualize what the AI is answering. We need to see what the AI is doing over time. This is going to be kind of for me, it feels like obvious what we're going to see, what the outcome is going to be visually. It will be neat just to try it out. Maybe there'll be a small little of insight. We can also use it to help understand as we're optimizing and we're tuning the model using various different optimizers or loss functions, what it looks like different visually. And one of the future streams that I want to do that I think will be really neat is using every single loss function that Pytorch has to offer. That would be a fun, that's a neat, in fact, let's write that down really quick. Let's write that down really quick. We'll go here, 1, 2, 3, future stream idea. Use every loss function available in Pytorch. There we go. Pytorch. Perfect. All right, that's future stream idea. All right, so the plan for today, let's get going. We're going to implement the heat map. We're going to start with the heat map here. All right. So in order to do that, we need to track all the output that we've gotten over time, every single AI output in an array. So let's do that. Let's make that happen first. Okay, so where do we want to do that? So what is this for? AI list. Set AI prediction pixels, coordinates, output coordinates. Do we already have it? Do we already have it? No. Okay. So this is the current number, and we need a historical number, so we can blit the output to the screen every single frame, and we'll do this in a way where hey man, Ahmad, how's it going? Good to see you. We're on the track to adding a heat map. So we're just sitting down. We're seeing what we want to design from a data retention perspective, and then how we're going to render it on the screen. This will be pretty neat. So right now we are storing the coordinates. We want to add in, hey Savon, how's it going? Hey Savon, good to see you. Happy Thursday. We're going to do the thing that you requested. The thing that you requested was implementing the heat map. So we're going to be, it'll be sort of a light map in a way. I don't know how heat oriented it'll be. We'll see how far we get. Good to see you as well. Yes, nice. Excellent. That's awesome. So I'm going to have like history. So this is like AI history output. So we need to do something like this to append like that. So that way we get every single coordinate recorded. Then we need to add this in. Let's see, it's previous. Here we go. Let's do this. We will do underscore autocomplete. Oh wait, pointless. We have so many lists in here. A little too of. We've added that. Now we need to render it. We might get done with this really fast. We might be on a new record. I mean, this is like really easy stuff here. So we've got that. Now this is, where's this being rendered at? Game. Okay. Coordinates for the AI prediction. Where is this at? Okay. Draw circle. So this is, we need to do a for loop. Here. Is there a better draw? Maybe we can write a function. Let's write a function that does this for us. So let's see. Def draw heat map, and then we need a game. I believe just the game object, and that's it. I believe that's it. That's all we need, just a game object. Then we'll just copy and paste this. Draw heat map game. All right, looks good there. Been playing around with llama. This goes into output. We're gonna do this. Oh, you know what we should do is we should say chords like that. Let's say chords because it's a little more obvious. This is gonna be X and Y chords, right? Okay, so this will work. The only thing is I need to see what the background color is. And also let's read some docs. All right. Let's go over here. Pytorch. Oh, no. Pygame, which is our rendering engine. Circle, draw, and can we do opacity? Can we do that? Can we do semi-transparent? Maybe. Maybe gonna highs, obvious or not. Python again. Let's go, right? Yeah, there you go. Yep, Python again. You got it. You got it. All right. Use separate transparent enabled surface and you blit onto your main display. Okay. So we might be able to do this. Okay. So we draw onto our circle surface. We need a separate surface that we create here, circle surface. So that way we can get some transparency. That sounds good. Then we fill the screen and we blit the circle surface. We probably need, yeah, it probably does need to be an in-game. So we could say Heatmap. Heatmap is a, what do you call it? Is a surface. Do we have anything? Yes, Pygame surface. Perfect. Heatmap. Excellent. There we go. Boom. All right, we got our heat map. We got our heat map. All right, we're making it happen. And it would need to be able to analyze that way. So it's a lot of logistical data putting into the system. So if you can solve that, you probably will do very well. You do very well. All right. So we need, so that we've got the screen here. All right, so heat map surface, good. We want to initialize the surface where we got this screen. Screen. Where is this at? We need to initialize it. Okay. Did we put it here? Circle surface. So this will be game.heatmap. Will be a surface, and I want it to be exactly the same dimension. So let's do screen equals this. All right. So we'll make screen equal to this. Equals that, and then we add that here. And it needs to be the same resolution. It needs to be exact same resolution. Screen. Here we go. Screen. Okay. All right. So we got the heat map. We got the game window screen. And then we blit onto, or we render onto the heat map, every circle. And then we blit the heat map onto the screen. And that should work. That should work here. And we need to put this down lower. I'm gonna write this here because it's easy to see. Or we could do a split screen, reference that, go down to the section where we do need to draw it, and here we will draw it before the all right. So we draw the heat map here. Perfect. Okay. Redo screen blit. Well, we need to do this once here. After, so I do believe, okay, so draw a circle onto the heat map. Wait, game.window, hold on. One moment, where is this window? Okay. I guess we could say, this is being doubled up, isn't it? Wait, hold the phone, okay. So, we need to put this here, so otherwise that won't work. Okay. Then make this prettier so it's easier to read. Okay. All right. Heat map looks good. Screen. Here we go. All right, that looks good. Oh wait, the heat map's supposed to go here. 1 second. We need to do this. Heat map equals, like that, and then we need to here's what we got to do. This is what we got to do. This has to be 900 by 500, and this has to go up here. We got our heat map. We've created the surface, which is, it has alpha. It's got alpha in it. Now we need to blit or draw onto this surface. That's what we have to do. We have to draw onto the surface. Where is it? Heat map. Okay. Let's see, our heat map draw is functions here. Game.draw.circle. Game.heatmap. I think. I'm pretty sure. Heat map. Okay. Then we've got the coordinates, the size of the circle, and then we also need to add the opacity somehow. That should be in the docs here. How do we do this? Let's see here. Oh, I see a fourth one. Okay, here it is. So here's number 4. This is the translucency level, 0 to 255. Excellent. So I will put on a, we'll do 120. Keep everything nice and smooth. All nice and smooth. Okay, so that should give us some translucency there. essentially in the middle of translucency. Let's bring this up to 255, so it's a little bit hotter. 255 here as well, and then 128. Excellent. And then, yeah, sounds good to me. All right, so this will be the color. So we'll draw that onto the game surface, which supports, and this should be 0, 0. Okay, 0, 0. 0, 0. Looks good. Okay, so we blit the circle surface onto the screen surface right here. Obviously, that's not going to work. It's called game.heatmap. That's what we need. So yes, we did miss something. Game init missing one required positional argument AI history. Ah, yes, all right. I remember that. We just need to initialize it to an empty list. So game, here we go. Right here, AI history equals empty list. All right. All right, there we go. We're onto it. Hey, we did it. We did it. Look at that. Now you're seeing all the. It's not perfect yet. It's not totally perfect, but it's better. You can see it's not like a heat map. It's just more of a, hey, where has it been over time? This is actually pretty great. You can see what the visualization is we need to here. Let's increase the number of coordinates. Let's go 8, and then we also need to update. So there's number of XY coordinates, number of features. So yes, there are 8 input features. Right? 8 input features, which means that our model, which is around here somewhere, model, here, needs to be 6, and then 2 output, right? So there's actually, so 8, -2, offset means 6 features, or 3 X's and 3 Y coordinate. So that will be a total of 6 input features. Let's see what that does. Let's see how that changes it. All right, here we go. Is that going to make it better or different or the same? It looks like it has made it center a little bit better. It's like making a weird little... Is it going to make it... What is it? A shrugging symbol? I don't know what it is. I'm not exactly sure. We should make the heat map a little prettier, though. Okay, let's get back over to this. All right, we got 30 minutes. We got plenty of time to mess around with our adventure here. Let's turn that decay off. Let's see if that works any different. Okay, let's try this again. All right, where are we at? Here's the outputs. Whoa, that's it, jumping around now. Look at that. Okay, so is it doing a little bit? I would say it's doing a little bit better. This is a little bit closer to what I want. See how it knows it's popping? Okay, so now it's not doing what I want. I need it to get close. It's very interesting to see how it's learning over time. This lets us know that it's not the right model. We need to improve the model. So it will then predict where the next click will be. We need to improve the model in a way to where it actually is starting to do that. Because I am clicking in a general pattern, mostly in a circle pattern, and so the AI should be able to learn those patterns. We might need to increase the number of features that we're using. We might need to change to an LSTM. These are the improvements that we need to make to the model, so that way it actually starts really predicting where the clicks are. Maybe we can improve our heat map. Can we make the heat map a little prettier? I suppose we could. We could make it a smidge prettier. How do we want to do that? I suppose we could... can we do a radial gradient? I think that would make it better. If we could do a radial gradient rendered onto the screen, that would be a lot nicer. Let's try that. Let's do that. Pygame draw radial gradient. Let's see if we can do that. Is it possible? It looks like it is, and it just requires extra code. Surface, center point, radius, start color, end color. Okay. How is it doing this? Okay. Okay. Then it renders, it walks through, takes, so we would have to draw this ourselves. There's no built-in native function. And I don't necessarily want to copy and paste this. Screen, red, blue, red to blue. We would convert this into also so I want it to be the main color and then taper out to a transparent color. So color step. Oh, so is it drawing? It's just drawing a whole bunch of circles. We could do that. We could absolutely do that. That's really easy. We can, and it would look heat map like, okay. I like that idea. I think that's pretty neat. We could do that. We could do that. We don't need the code anymore. We can do it. We can do it from memory. Draw heat map. All right. So we can do that. All right. Let's do that. I think this will be fun. This might be the last thing because we only have we got 20 minutes left. Hashtag exclamation today. Fractal cow. Hey, how's it going, Fractal cow? Good to see you. Merry Christmas. So we make it scattered, enlarging the turning red from green circles where the rate of clicks. Yes, exactly. So before I get to the changing of colors, which is right here, I want it to a radial gradient. I want to draw a radial gradient. So I have to draw the outer circle, the big circle first, which is lightweight, because it seems like when it's blitting onto the surface, it's replacing whatever it blits over. So I'm drawing inside to outside right now, which is going to overwrite the circle gradient, the radial gradient. I need to draw from the outside in. So we have to start big to small is what we have to do. We have to go big to small. So how do I do that? Negative I, we'll say 20. 20. And we subtract. Here, I've got an A. We subtract I times 2. Like that. Okay. So we go the opposite direction. So that right there, that one thing should make it visible. Let's see here. Python main. Okay, let's see. Does that make it visible? Yeah, there we go. If only. Okay. So it is kind of working. As you can see, though, it's taking the background color, and it is a radial gradient, but it's not actually alpha heat map. See this right here, source alpha. Let's do this. Let's grab this really quick. Source alpha. A flag used when creating a surface to specify that the surface should include a per pixel alpha channel, which allows for transparency effects. So let us also add this into our main window. That might help it. So where is our other surface? Surface. Screen. Where's screen at? Display mode. Set mode. Can we do this? We can, but it didn't do anything. It didn't do anything. It looks great. It looks great. You can see it's just I want the alpha channel to be preserved. What are you trying to build here? I just started watching you. Nice, excellent, Abhishek. So we're doing a click tracker. The AI learned to predict the next click. As you can see, the AI is learning. It's just not learning in the way that I want it to. So what we're doing, Savan on here and others were saying, hey, we need to visualize how it's learning over time. And so that's what we did today. We added the heat map. However, we ran into a technical challenge where the heat map, we need to have an alpha transparency. And you can see that I added radial gradient rendering, which I just added. However, it's not preserving the transparency every time I overwrite the surface area. So we need to do something a little different, because every time another circle is drawn on top of the previous circle, it completely eliminates the previous rendering. And so I'm trying to figure out what's a good way to deal with that, which we might have to save until to drawing brother surface better. Surface heat map. Window blit. Let's see if we can ask the AI for help. The transparency is not preserved for each circle. Is there overlaid on top? Let's see if there's a way to preserve the transparency. Draw circle, do not perform alpha blending. Yes, oh, that's what we need. We need alpha blending. I didn't know that was a separate thing. Yep, art red, green, blue, alpha. You got it, Kyle. You got it. Red, green, blue, alpha. So we need to do blending. Draw blend circle. Target surface, color, central radius. All right. Center radius, center. Okay. So there's a separate blit the temp surface onto your main surface. Draw the circle to the temp surface, which is what we did. That's wait, no. Okay, good. Okay. Where is draw blended circle? Create the temp surface just for the circle. All right, so we got one temp surface. Okay. Then we draw the circle onto the temp surface, and then we blit that onto. It looks pretty good. It's kind of hard to see. I'll brighten that really quick. I'll brighten that. So let's bring this up to 25. So it'll be very bright. There we go. Here we go. So there. Now you can see. The only thing that's not happening is not preserving the transparency for every single circle that's rendered. As you can see, it's you see this trail here, sort of like a trail that's happening. And I want it to look more like a heat map. Theo is light. Thank you for your subscription. I think I can actually capture your screen or your current mouse position, and then eventually you could even have it monitor your daily clicking activity and possibly predict what you do next. If it had enough data, your